Hey guys, welcome back to another video, and today we'll be learning about the new features going to be introduced as a part of ES2020 in JavaScript. So there are 8 features planned given in the list which we'll be looking today. To know more about the features, you can visit the GitHub page. On this page at the bottom all the features are given, and if you click the links you can know more about their status, syntax, etc. There is also another link which is handy as it has all the browser compatibility table for all the features together. I'll also add the links in the description for your reference. So first in the list is match all. This is improvement over the string.match, which gives you an iterator of all results matching a string against a regular expression, including capturing groups as well. It is similar to the match function when you use match function without a /g flag. You get an iterator here which can be looped or converted to an array depending on how you want to use it. The result contains the matches along with the properties such as groups, index, and inputs, etc. In case of no result, it will result an empty iterable object. So let's see this through an example. So we'll be doing this example in our browser console only because Firefox and Chrome both have started to support it. So suppose I have a regular expression a of this type where will be searching for some strings of type test1, test2, and then it has some optional things as well. And then you have a string stored in variable b which is of sort this is test1, this and test2, just a sample string, nothing more fancy. Now when you do b.matchAll a, it is going to give you an iterator containing all the results. So we can either loop through it or we can convert it to an array. For now we'll convert it to an array and see what it contains. So this is giving me an array with length 3, 0, 1 and 2. 0 contain test1, then est1 and 1, and first contain test2, est2 and 2, and similarly you have test3. Now if you further open it up, you will get some additional properties such as index, input, length, similarly for the first index and similarly for the second index. So index is basically the first matching which is found, length is the length, and then input is the input string. Next we'll save our results into a variable and we'll just loop through it. So this could be done easily. Each of these iterators have a variable as done. So done is false or true. So till the time your done becomes false, it means you have some of the values. So that is what we are doing there. So till the time your done becomes false, you just loop through it and you assign the next value to the variable c. So yeah, now you get the 3 arrays basically with the same format which we have seen earlier. Next in the list is dynamic import, which is on-demand import of libraries and modules. Dynamic import returns a promise which can be resolved and then assign it to a variable which can be used later on. It is very much useful in lazy loading modules, which helps to increase the performance of the website. We have discussed about this in React Lazy video, so for those of you who are React.js developer, they can go ahead in the cards and see how the lazy works. So let's look at an example here and we'll see how dynamic import works. So for learning about dynamic import, I have just created one index.html file in which I'll be importing two functions, one using dynamic import and one using normal import, and we'll see how it goes. So I'll be adding a file, say add.js, which will contain an addition function, and then sub.js, which will contain subtraction function, and then we'll import it. And in my index.html, I'll add one script tag with type is equal to module. So this is a normal import, which is import add from /add.js, and then I'll just console log add. And the subtract one will be a dynamic import. So how we do dynamic import is you have a variable equal to import, and inside the bracket you give the file path. So we'll open this in our browser or via simple Python server. So if you see in the browser here, what I have is for add, you are directly seeing the function, but for subtraction or for sub, it is a promise which has been fulfilled, as in which has been resolved, but it's a promise here, and add is a function here. Next, what we'll do is we'll try to call all these functions and we'll see how it goes on. So for addition, since it's already imported, you just simply have to call your function, which is add, and then calling the function. But for subtraction, since it's a promise, so we have to do sub dot then, or we can use async await as well. And then now my module contains the library, and since subtraction was a default function, we'll do module dot default, and then we'll call that function. So this is how we have to use for a dynamic import. We again go in our browser. So you see here that the first one is addition, which is done fine, and similarly the subtraction is done fine. And as we have console log the function, as well as that is logging the promise. Next is BigInt, which is going to be the 7th primitive data type and is similar to a number. That is, if you do double equal operation of BigInt with number, it will give you a true, but triple equal to give you a false. And it will also be useful when you have numbers more than 2 raised to the power 53 minus 1. Basically, till now, if we do operations for number which are in the order of 2 raised to the power 53, we get unexpected result, because that is the maximum safest value of integer which JavaScript has promised. So this will stabilize those results and will help us in doing operations on those big numbers. So let's see this through an example. So to create numbers of type BigInt, we have to directly call the function BigInt with containing number, as I have done here. Say BigInt, inside bracket I have 10. It creates a number of type BigInt, or you can just write number n at the end of any number like 11n. So it's a type of BigInt here. So BigInt numbers are succeeded by n. So 10n or 11n is a BigInt here. And if you do a type of a, it won't give you a number, it will give you a BigInt. Or similarly, if you do type of b, that is also a BigInt, and the addition, subtraction and multiplication will all work fine as we are doing here. But if you have another data type number, like c is equal to 11, which is a number data type here. So if you do a plus c, it will fail here. JavaScript doesn't implicitly converts BigInt to a number, so this will give you an error. So let's see what problem BigInt is going to solve for us. Say this is the number max safe integer which we have. Normally, if you try to do any operation such as maxint plus 1, it's fine, but if you do plus 2, you see that you are not getting the correct result here. Similarly, if you do maxint plus 3 or 4, sometimes you might get correct result, sometimes you don't. Like for 4, you are not getting the correct result, because at this point JavaScript doesn't guarantee you will get the correct result, but we can fix this using BigInt. So I'll convert this number into a BigInt. Now if you do calculations such as number plus 1 and it's 92, number plus 2 and it's 93, so you see here that calculations are now fine. So this will help to do a calculation of very big numbers. So BigInt is loosely equivalent to number, but not strictly. So that's why if you do 1 and double equal to 1, it gives you true, but 1 and triple equal to 1, it gives you a false, because the value is same but the data types are different. So next in the list is Promise.allSettled, which is a new method added in the promises, where it will return a promise which will resolve only after all the promises have been fulfilled, whether success or failure. The resolve promise will contain an array of objects with status as fulfilled or rejected, along with the value or reason. An example here will clarify it more. So we'll be doing this via node. So for promise.all settled, I'll just create 4 different promises. 2 of them I'll be resolving it, 2 of them I'll be rejecting it, and it will be basically a set timeout of 1 second to 2 seconds, and we'll see how we get the result and what the result contain. So here I have 4 promises, and then I'm doing promise.all settled with calling it an array, and then inside then I'm logging the result, and inside error I'm logging the error, whatever if happens. So you have node promises.js, and now you see the results are here. So for the status of 2, which is the first and second, is fulfilled, but the last 2 are rejected. So if you see here, you have a status which is fulfilled or rejected, and then you have corresponding values, which is values pertaining to resolve A, resolve B, reject C, and reject D. So next in the list is globalThis. This is mainly getting introduced to standardize the global object across all platforms in JavaScript. If we try to get global object, we need to use different keyword in different platforms. In browser it is window or self, in node it is global, and in web workers it is self. This will standardize it, and everywhere you can access the global object using globalThis. Let's see this in our browser as well as in node. So if I go in my browser console, to get the global object, I can type in window, or I can type in self, or I can type in frames. This will all give me the same result. Similarly, to get the global object in node, I have to use keyword global, because window or self or frames is not defined. For node, I have to do console log global to get the global object. You can easily see it here. But if I do the window or self, then I'll get an error here, because window or self or frames is not defined in node. So this behavior will be standardized by globalThis. You can use globalThis now in the browser to get the global object, which is window, and in the node, if you do globalThis, you will get the global object. Next is for in mechanics. Till now, the order of properties is not specified for A in B, so different browser handle it differently. While this works fine as long as we stick to one browser, but a cross-browser compatibility is the issue here. That is going to be fixed here, and the behavior will be standardized. The second last in the list is the optional chaining operator. This operator is already present in a lot of languages, and JavaScript will be introducing it soon. It is similar to dot operator in accessing some value from an object, but won't throw the error in case the value is null or undefined. It will return undefined without throwing an error. Say if you have an object A which contains a key B, and if you try to access A dot B dot C dot D, so here you will get an error because C is undefined, due to which D is cannot read property D of undefined, but you can use the optional chaining operator here to avoid the error. We'll see this through an example. So as of now, Firefox and other browsers have not started to support optional chaining. To see this example, we'll actually go into the code pen, and there we'll use it. Just go into the settings and just select the Babel as your preprocessor, and it will all work fine. If I have an object A which contains B, uh, which itself contains C, so if you console.log a.b.c, you will get test. But if you console.log a.b.c.d, it will give you undefined. Again, if you try to access E from D, it will give you an error. See, type error, this is not defined. So one way to resolve these kind of issue is to use AND operator. See, basically a dot b dot c dot d double ampersand a dot b dot c dot d dot e. So it will basically, since d is undefined, it won't run the right part of the AND operator and your code will work fine. But this will be a issue in case you have an object, say it's coming from an API response, and you don't know at what level you won't be getting the key. Say you don't know whether B is present or C is present or D is present or even E is present. So you have to do a lot of stuff like a double ampersand a dot b double ampersand a dot b dot c. So this will lead to a very big condition and it might become confusing at time and is error prone. So optional chaining operator will help us here. So you can do a question mark dot b question mark dot c and so on. And what it will do is, in case the value is undefined or null, it won't throw an error. It will return from there giving you the undefined value. So here you see, for the condition which we have written, the longer one is undefined, then for the shorter one also it's also undefined. And if you know at what point you won't be getting the key or you will be getting undefined or null, you can only use optional chaining operator at that place only. And after that, how many times you use the dot operator, at from that place it will return undefined without evaluating the next expression, and so you won't be getting the error. And the last in the list is Nullish Coalescing operator. This logical operator will only evaluate the right hand side if the left hand side is null or undefined. It is similar to logical OR but a better check against falsy values. When you are using OR operator, it might give you some unexpected result in case of falsy values. So let's see, in the table given below we have a variable with some falsy values and the outputs are also given. So in the table, as an example, a has a value 0 or empty string or null. So basically all three falsy values. So say if you do a or 10, you will get 10 in all the cases because all these are falsy values. So this will become an issue where you need 0 as a valid value or where you need the falsy values as the valid value. So if you use the Nullish Coalescing operator, which is a question mark 10, then for 0 you will be getting the result 0 instead of 10. Similarly for empty string it will be empty string, and only for null and undefined you will be getting the result as null or undefined. So for Nullish Coalescing operator, we'll have a as an empty string, and if you console log a or temp, you will get temp as the result. So there could be a case where you need the empty string as a valid value or it is a valid response, and you want on the default value, which is temp here, to be assigned only when you have null or undefined. So Nullish Coalescing operator will help here. You simply do a question mark temp, and now if a is empty string, you will get this result as empty string. Similarly, if a is a number, when I assign a to 23, I am getting the correct result, which is 23. But if I assign a to 0, I'll get the 0 irrespective of 0 being the falsy. But if you use the pipe symbol here or operator here, you won't be getting the 0, you will be getting 100. If a is null, then only you will be getting the value as 100, or if a is undefined. Similarly for boolean values as well, if a is boolean false, so in that case also you will get the false as the result instead of 100. But if you do pipe symbol or if you do the OR symbol, you will be getting the 100 as a result. Conditions where it behaves like an OR operator is when the values are null or undefined. So this is all about the new ES2020 features in this tutorial. Hope you like it. Also, I have created some other awesome videos in my channel. Please check those as well and subscribe to the channel for more videos like this. Thank you.